In this example, we will solve a rational equation. So step 1, find the LCD. Well, the LCD has to do with the denominator. So in the first expression, we have a factor of x plus 2. In the second expression, we have a factor of x plus 3. Since there are only 2 factors involved, then those are 2 to combine would be your LCD. So my LCD would be x plus 2 times x plus 3, because at most each factor occurs only once in either denominator. What do we do with our LCD? Step 2, we're going to multiply both parts. We have 2 parts to this equation, so both sides of the equation by the LCD. Why do we do that step? The whole reason for that step is to cancel out your rational expressions or your fractions and leave you with just a clean equation for which you solve for x. So on the left side of the equation, what can I cancel? Something from the top that matches something from the bottom. If you said x plus 2, that is correct. And on the right side, then, what would you be canceling? And if you said x plus 3, you are correct. So let's go ahead and cancel those terms. And we're going to bring down what we're left with. Here we're left with 2 binomials. And whenever you are multiplying 2 binomials, the only way to solve that is to use FOIL. First, outer, inner, last on both sides. Once we do that, our next step is to combine outer and inner, because outer and inner are like terms. So we're going to go ahead and combine the outer and inner terms of both polynomials on both sides. Once we do that, we are left with a trinomial on both sides. Now, anytime you have an equation, you are solving for x or whatever variable that is. In this case, it's an x. So in order to solve for x, I need to get all my terms on one side or get it in standard form if I'm going to use the zero factor property. So to do that, if the terms that are on the right side, I'm going to have to move them using the rules of equations. So the first term is 5x squared. To move that, I'm going to have to subtract 5x squared from each side. The second term is positive 9x. To move that, I'm going to have to subtract 9x from each side. And the last term is negative 2. So to move negative 2, I am going to have to add 2 to each side. So once I do that, what I'm going to be left with here is negative 2x minus 22 equals 0. So the next step to solving this, I could either factor out the negative 2 and use the zero factor proper further, or I can add 22 to each side. And then after I add 22 to each side, divide by negative 2. Remember, what you do to one side, you do to the other. And that will give me a solution of x equals negative 11. Once you get your solution, you must always go back up to your original equation and glance at the denominators. And just imagine plugging in your solution where x is in the bottom to see if, when you plug your solution in, does it make your expression undefined? Because if it does, then you have to discard or throw that solution out. But I can see here by plugging a negative 11 in x's place on both sides of the denominator, for either one, it is not going to make the denominator undefined. So in this case, I get to keep my solution. But just curious if you know how to identify those values that would make it undefined. Can you tell me for the first expression, what would make the bottom of x plus 2 undefined? If you said that if x were negative 2, then you are correct. How about on the right side of the denominator? What would make that denominator of x plus 3 undefined? If you said negative 3, then that's correct. So in other words, negative 2, negative 3, those would be the two numbers that would make the bottom undefined. If our solution were those two numbers, we would have to throw it out. But since it's not, our solution is negative 11, we get to keep that solution of negative 11, and there you have it, solving rational equations. And recall, you can always check your solution if you're not sure. Plug it back into the original equation. If you plug it back in and it leaves you with both sides that are the same, then that's proof that that value is your solution. So here we have a solution of negative 11.